Hey guys, Mrs. Traver here. We're going to work through our notes on 4142, linear versus nonlinear functions. 42 is about linear functions and the patterns that happen there, and 43 is about nonlinear functions and the patterns that happen there. So we're going to look at both of them together on the same notes. We'll get a t-chart going here. We're going to first look at what the graphs look like for linear and nonlinear, what the equations look like for each, and what the tables look like for each. So that's the game plan here. Let's start us off here then with linear functions. Linear functions are, you'll never guess, lines. It says line right in the title. So the graph of this is some sort of line. It could be one with a slope that's positive or negative. It could be a vertical line. It could be a horizontal line, but they are all lines. Nonlinear is anything that's not a line. So we could have a parabola, not a line. We could have a cubic function, definitely not a line. We could have a fractional function, so maybe one that looks like this. That's a little different one. Or an exponential function. There's lots of ones here that go in the nonlinear group. But anything that isn't a straight line, you can count as nonlinear. So there's our first bit. Our equations of those have some similarities as well. So equations of those, lines have equations with an x and a y term. So it could be like y equals 2x minus 3. There's an x term, there's a y term. It could be just like y equals 5x. There's an x term, there's a y term. They could also just have an x or a y. So like y equals 2 or x equals negative 3. There's only x's and y's still. They're all to the first power, so everything's good there. So all of these are examples of equations. The main thing to notice, though, is that all of them have only two variables, and that they're all to the first power, the power of 1. There's no exponents. So let's say only two variables and no exponents, or an exponent power of 1. So notice that this one has x to the first, so we didn't even write it. We just wrote 2x. Equations of nonlinear are all over the place, to be honest. So the parabola that I drew up here, that could be, for example, y equals x squared plus 1. Right off the bat, I see a squared term. This one I drew as a cubic. That could be y equals 3x to the third plus 3x squared minus 1. That would work. And this one could be one where there's a fractional exponent, or a fraction. So like y equals 2 over x. That would be one that would turn out something like this. Or some cool ones, y equals e to the x if x is in the exponent place. So if you've got anything weird going on with exponents or with variables in the denominator. So exponents on your variables or a variable in the denominator. The last thing I want to look at is the tables of those. The tables here, let's look at first the linear one. So on this one, if I was given a table of x, y values, let's look at some things that are happening here as a pattern. So notice that all of the distances between our y coordinates is the same. Each one went up 2, as each one of these x ones went up 1. So what we'll say here is that there's a constant rate of change. And in the next section, in the next chapter, we'll learn that that is really talking about slope. So if you can find a constant rate of change in both the x and the y, then you're good to go to say that that is a line. You could also graph those and check it. Over here, to check and see if this, to notice that this is a nonlinear. So looking at this one, this nonlinear function, notice that it went down 3, down 1, up 3. There's no common thing going on here. So no constant rate of change. And that is your major clue off that you have a nonlinear function. So we've got three different things we can look for: linear, nonlinear. The easiest thing to think about is the graph. Is it a line? It's linear. For the equation, if everything is to the power of 1, it is a linear equation. If not, it's a nonlinear. And then with the tables, if you can find a constant rate of change, you're good. If not, then it is nonlinear. I will see you guys next time.